Okay, so these are our base quantities that we made you memorize. How many are there altogether? 7. How many do I have here? I only have 5. Okay, so there are 2 more. They are all equally important. You need to know all of them. So on this side, I've got the SI units, which you are told to memorize. And you've got a symbol. What is the difference between SI unit and symbol? What is the difference? Do you prefer to do your working with spelling everything out, or do you prefer it with symbols? Why? Shorter, because we are all lazy people, right? Yeah, okay. So this is more convenient for us. Saves us a bit of time. So you must know the difference between an SI unit and symbol. When I ask you during the exams, what is the SI unit for time? What is your answer? What is the SI unit for time? Seconds. What if a student chooses to write S? Then you get 0 marks. Because that's the symbol. If I ask for SI unit, you must spell it out. Which also means you need to spell everything. Okay, spelling. You need to be able to spell all of them correctly. Alright? Okay, which of the following is the SI unit for area? What do you think? Oh, you saw the answer already, but how do we decide? What do you think is the answer? Okay, so A, B, C or D? C. How do you choose C? Because area is length times. Why are you telling me about length? I'm asking about area, right? So length and breadth, is that the formula for area? Is that? Okay, let me teach you a little. Area. Hang on. Area of rectangle. Okay, what is it equal to? Length times breadth. What about area of, what else you know? Triangle? Half times base times height, right? What else do you know? Circle, okay? Area of circle. What is this equal to? Pi times? No. Radius times radius. Okay, you see from our worksheet, what is the SI unit for area? Did it say area for which shape? They didn't say, right? So how are we going to decide? Does it matter? Let's see. Okay, what are the SI units for length? Over here. You said area of rectangle is length times breadth, right? What's the SI unit for length? Meters. Okay, I'll just put it at the top over here in brackets. Meters. That's a unit for length. What about for breadth? Meters also, right? So if I take meters times meters, what do you think I'll get? Square meters. You shouldn't be saying meter square. It's known as square meters. So area of a rectangle has the units square meters. Agree so far? Okay, makes sense? Same for square, right? Okay. What about the next one? Area of triangle. I've got a half. What is the unit for half? Are there any units for a number? Number has no units, right? For example, 1, 2, 3, they are numbers, there are no units. What about this over here? Base. What is the unit for base? In SI unit? Meter also. What about the SI unit for height? Meter. Okay, so over here, no units. Then meter times meter, what do I get? Square meters again. Look, the area for a triangle has units of square meters as well. Okay, and we obtain the square meters from all these units. And I used SI units. I didn't use centimeters, I didn't use kilometers, I didn't use anything else. I only used SI units. Okay, now, last one. For the circle, what is the unit for pi? No units, it's just a number. What is pi? Yeah, okay, 3.1415992, blah, blah, blah. Okay, I can't remember anything beyond that already. So, it is just a number, it has no units. What about radius? What is the unit for radius? Meters again, in SI unit, over here. meters. Multiply them all, I get square meters still. So this is how we conclude that the SI unit for area is going to be square meters. Okay? We can use this approach for all different types of questions. For example, I want the SI unit for speed. The unit will be, what is the SI unit? How much is it? Kilometers per hour. That's what I see when I drive. Is it correct? For SI unit. Okay, so SI unit, what should it be? Meters per second. Because we have all memorized that the SI unit for length is meters, the SI unit for time is seconds. Nothing else. Okay? So here we've got answer C, square meters. How many square centimeters are there in 1 square meter? I tell you, I know that A is definitely wrong. What else is definitely wrong? D? How do we decide? How do we decide what the answer is? How many square centimeters in 1 square meter? Okay. How many square centimeters in 1 square meter? How do we do this question? Did anybody teach you before? Have you done conversion in primary school for this? Or how do you do it? How did your teacher teach you? 1 meter equals to 100 cm. So 1 square meter equals to 100 square cm. Yes? What primary school you all come from? Are you sure this is correct? This is wrong. Don't scare me, don't scare me. Okay? That was wrong. I will now teach you how to do it properly. 1,000? How do you get 1,000? I will teach you how to do it properly now. Watch carefully. Because next time I will give you a question. How many cubic centimeters in 1 cubic meter? Then you need to do it. Okay? So the same approach will work. Okay, change this back to the original question. Now, can we all agree that 1 meter is 100 centimeters? Yeah, we all know that. If I want 1 square meter, how do I obtain 1 square meter? I take 1 meter times 1 meter, right? This is 1 square meter. Agree? Agree? Okay. Let me rewrite it. 1 square meter is actually equals to 1 meter times 1 meter. Now, how much is 1 meter in cm? Oh, you all already, you all know how to do it already, right? Okay, multiply by 100 cm. What do you think is the answer now? What's the answer? 10,000 units. Square centimeters. So what is the answer? It is D. Okay, do we need to memorize this? Do you need to memorize? After I've taught you this, do you need to memorize? Why do you need to memorize? Just work it out lah. Right? Can you work it out by yourself next time? Okay, I'll give you another question to try out. How about how many square millimeters in 1 square centimeter? Okay, how about this? Can you do this? Give you some time to do it. 10 and 10. Answer? 100 square millimeters. Is it difficult? No, it is not. Do you need to memorize? No need. You can all do it. How long did it take you? Yeah, less than 10 seconds, you're done already. Okay? So, for some students, if you're being stubborn, you want to memorize, go ahead. I'm not stopping you, but you will be at a disadvantage. Okay, so answer D. Okay, which of the following has the smallest mass? By the way, just to check, are your answers in a notes the same as mine?
No.
Okay, what do you have for B?
For B, we got 10,000
10,000
milligrams.
milligrams. Okay, is everything else correct?
No. C is 1,000 milligrams.
1000 milligrams, okay?
D is 10,000 grams.
Then this is
10,000. H, what grams?
10,000 grams. 1 kg. So sure now? Is it correct already? Same as yours, huh? Okay, now we are ready to work. Everything has different units. What do you want to change them to? Your choice. What do you want to change them to? You want to change it to grams? Okay. 1 kilogram equals to 1000 grams. Right? So now I've got another two to decide. How much is a milli actually? What milli? No. Milli. Milli refers to M-I-L-I or M-I-L-L-I? It's 1 over 1000. Right? Millimeter. How much is 1? We've got 1000 millimeter equals to 1 meter, isn't it? Right? This milli over here, this little m, refers to 1 over 1000. Just like milligrams. It is 1 out of 1000 of a gram. Okay? Yeah, so now let us work it out. This is actually equals to 1000. Then now this milli over here, like I said, it is the same as 1 over 1000. And then the gram, I bring it down gram. You see how I'm doing it? I'm converting the m, the little milli over there, I'm converting it into a fraction. And the fraction is 1 over 1000. So what is the answer? 1 gram. Okay. For part B, okay, you will see the answer, but it doesn't matter. We all want to learn how to do it. This over here is 10,000. Now, milli. Change the milli to a fraction. How much is that? 1 over 1000 grams. Okay, I'm going to highlight this m refers to this 1 over 1000. This g over here refers to this g over here. And the 1000, no change. Sorry, 10,000. Okay, see how they are equivalent. With that, let us use our calculator to find out the value. So this gives us 10 grams. So which is the smallest mass? Which is the smallest mass? C. Yes, you are right. C. Can? Any questions? No. Which of the following has the largest area? Don't worry if you can't copy, because they will be uploaded on YouTube. You can go and watch it anytime you like. Which one is the largest area? Is your answer all the same? Are your options the same? Or is there any error? Same, okay. Now we've got things in square centimeters, things in square meters. What do you want to change it to? Change it to square centimeters. Okay, can we do that? Okay, I've got square centimeters, square centimeters. What is this in square centimeters? 100 square centimeters. Am I right? Am I right? Right or wrong? Wrong, huh? We just did it a while ago. This is 10,000 square centimeters. Okay, and I want the largest area. I want the largest area. Do I need to consider C? Should I go and find out how much this is? No need lah, because I know that 1 square meter confirm bigger than 0.1 square meters, right? I will eliminate this. If you like, you can convert, up to you. So now with this, which is the largest area? Which one? D for? B or D? Which one is it? D for dinosaur? Dinosaur, D, yes. Okay, D is 10,000. B is only 1,000. Okay, what will you use to measure the diameter of a beaker? Okay. If we consider measuring tape, what else can you use? Vernier calipers. Anything else you like to use? Why can't you use a meter ruler? What? Wait. Are we measuring diameter or circumference? Are they the same? Are they the same? Okay, let's see. I will be using the board for this. Okay, moving on. Where should we place our eye to get an accurate reading? Okay, this one over here. What do you have in our notes? C. Okay. What is the error? If you read from A, is this B? A D. Okay, B and D. What is the error if I read from A, B, or D? What is it? Parallax error. Is it difficult? Is it difficult? No, it is not difficult. I remember that this will go and learn how to spell it. If you spell it wrongly, I will give you 0. Okay? Because it's a totally different word. How many L's are there? How many L's? How many A? Okay. Next. Okay, you may copy this down first. I will go through it in a short while. Maths. So, a very quick one. 10 to the power of 9. Hang on. So 10 to the power of 9 simply means 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. Okay? This is 10 to the power of 9. What do you think 10 to the power of 3 looks like? Okay, that's 1000, right? What about 10 to the power of negative 3? Okay? Okay, so this is what it is. 10 to the power of negative 3 means 1 over 1000. What about 10 to the power of negative 6? What do you think this is? Okay? So this is what it means. Can? Is it very complex? No. Why do people want to write this kind of things? Why do they want to use this instead of this one, which everybody knows what it is? Yeah, short form. It is easier to write all this in working. Can you imagine if your primary school problem sums, this person has this amount of grapes, then you have to work with it. So many numbers to write, right? So it becomes very difficult. So we have all this short form over here to help us. Okay? Okay, back to the notes. Okay, we've got 10 to the power of 9. It is known as giga. Okay, and it is a capital G. What happens if I put a small g? Then what does this represent now? Grams. Okay, so please be very careful with what you use. Have you heard of this term, giga? Have you heard of this before? When? Gigabyte? What does that mean? When? What is gigabyte? Gigabyte. What is this giga? When do we use this word gigabyte? Phone? Data plan? Okay, storage, yes. For example, my phone over here, 32 gigabytes. Okay, I've got 32 gigabytes of space. Okay, what does that mean? Is that a lot? Is that a lot? No, not a lot.
The max 128.
A lot or little depends on what you are comparing with. Let us see exactly what this number is. So 32 giga. 32 giga. How much is giga again? What's a giga? 10 to the power 9. 10 to the power 9 means 2, 3, 4, 5, 6, 7, 8, 9 bytes. Okay, so my phone has this amount of bytes. Is it a lot?
No.
Depends. Depends on what I'm using it for, right? Okay. Now, a photograph. Let me check one of my photographs. Okay. Details. Apparently, I've got a photograph that is 148. What does this mean now? A photograph. Okay, this means the photograph space, okay, equals to 148. How much is this K over here? Kilo, right? So how many times how much? 1000 bytes. Okay, so this is actually 148000 bytes. Whereas this is 32,000 bytes. Okay, obviously this number is bigger, right? How many photographs can I store inside here? The number divided by that number. Can you imagine if I use all these zeros and I start to divide? Very troublesome. So if I have things like 10 to the power of 9, and over here 10 to the power of 3, it makes things easier when I calculate. Okay, so we have seen the word giga before in our phones. It simply means 10 to the power of 9. It is a big number. Okay, so we use the symbol G. What about the next one, mega? 10 to the power of 6. How much is 10 to the power of 6? How many zeros are there? 6. What is that number? 1, 0, 0, 0, 0, 0, 0. Million. It is known as a million. 1, 1, 2, 3, 1, 2, 3. That is 1 million. Okay? So, mega with a capital M. Okay. Have you already memorized that giga refers to 10 to the power of 9? Have you already memorized that? If you haven't, you need to memorize, okay? Next thing you need to memorize is mega. 10 to the power of 6 is mega with a capital M. How I memorize? I remember it as million. So they all start with M. You may use this way to help you remember if you want to, or you can use your own way to memorize if you want to, okay? So million, mega, M. Next, we've got 10 to the power of 3, which you're all very familiar with, kilo. In primary school, kilograms, kilometers, or 1,000 times. So now we go smaller. So you see from a big number, we go down to become smaller. We go to milli now, M-I-L-L-I, with a little m. It is referring to 1 over 1,000. Okay? So we go even smaller, we've got 1 over 1 million. This is known as micro. Okay, have you heard of this word micro being used before? Micro. Micro something? Microscope. What are we looking at with a microscope? Looking at something really tiny, right? Okay, what else? Micro something? Microscope, microorganisms, small organisms. What else? Micro what?
Microscopic.
Okay, any more? Any more? Micrometer, screw gauge. Yeah, I mentioned that. Any more? Micro.
Soft.
Micro.
Microbyte.
Microphone. Okay, that's not what I was expecting. Micro SIM card. SIM card. Okay. Yeah. So, how does a normal SIM card compare with a micro SIM card? Micro SIM card smaller, right? What about the next one? Nano. Is there such a thing? Nano SIM card? Is it even smaller?
Yes.
Yes, it is. So they get smaller and smaller. Okay. But when we use it for SIM cards, it is just a name only. It doesn't mean that it's so tiny that you can't see it. We can still see our SIM cards. Okay, next thing over here is the symbols. Out of all the symbols on this side, they are all letters found in our alphabet. Okay, except for this one over here. How do we write this? It is like a U with this. This is micro. Okay, so you need to know how to write it. Because this is not from our alphabet, it's probably Greek. I do not know. Okay? So that is for micro. Now, for conversion. Conversions, please check that you have the correct answers. I will not spend too much time on this because you should all be able to do it. How do we read this? Find the zero. Your eyes look at the bottom first, right? Okay, find the zero. I found the zero. What do I do next? Find above, just before it, right? So this value. So I write down, oh, it is 1.0. Okay, because if the zero was just after this, it would have been 1.1, right? This will be 1.2, so on and so forth. This is 1.7. So if it is at this line, it will be 1.0 something. Okay, what is that something? 1 point. Find the what? Oh, find the matching line. Is this the one? Okay, so 1.04 units cm. You need the units. 1.04. Okay, next. Next one, B. What is the reading? 13.4. This one over here, right? 13.4 and 5. Okay, 13.45 units. cm. Okay? Yeah, no units will be wrong. You must have the units. Yeah, you have to mark your own work. Are you marking your own work? Yes. Are you doing the corrections at the same time? Yes. Next, part C. What is the reading over here? This one? Should we look at this? 6.8. What? 9. Yeah, 6.89 cm. Easy? Okay, next, 0 errors. Do a quick recap. Durian seller is weighing scale. If there's no durian, what should it point to? 0. Vernier calipers. If I'm not measuring anything, I close it up. What should I see? 0, 0 in one straight line, right? Okay, do I have that in question 11? No, the vernier scale is slightly to the left or right? It's slightly to the right. That means it is telling me that there is something there. But is it correct? No, there's nothing there. It should have been 0, 0. Instead, it is telling me, I'm giving you a reading of, what is this reading? 0.09. Okay, so again, the reading is the same. 0.0 over here, 9 over here. 0.09. What are the units? Units. I need units. cm. Is this correct? Is this complete? Okay. It is partially correct. Something is missing. What is missing? Positive or negative? Positive. I need the positive sign.
So that means right, no positive sign, no mark.
Yeah. I must see the positive. I know your primary school teachers tell you don't need write positive, but I need it over here. This is physics.
Sure, that's good.
Yes.
That means right, any student just say, I don't want to, what if the prime minister?
No, don't care. Still 0. Okay, next one. Over here we've got, again, positive 0 error. Do you know how to tell whether it's positive or negative? How? Okay, the vernier scale is on the right, that is positive. Vernier scale to the left is negative, right? So in this case, positive or negative? Positive again. So this is positive, how much? 0.02 cm. Very good. Okay, do your corrections, if any. Next question. Okay, positive or negative 0 error? Positive or negative? Negative, because the vernier scale is slightly to the left. So I write down, this is negative. How much negative? 0.0? How do you know 4? We start counting from the back. Yeah, we count from right. 1, 2, 3, and 4. Look at where they coincide. Okay, negative 0.04 cm. Last one. Again, it is slightly to the left. This will be negative 0.0, how much? How much is this? 6 cm. Okay? Can I move on? Determine the readings from the vernier calipers. Now, how do I get corrected readings? What is the formula? How do I get the corrected readings from a vernier calipers that had a zero error? You choose to either minus or plus. When do you minus? Oh, when it's a positive error, you minus, is it? What about? Ah, okay. Wait, hang on. I will clarify on that. We are all certain that we will minus away positive zero error, correct? Now the question comes for negative zero error. Some of you say that we just simply add the number, correct? For example, if I have a negative zero error of 0.06, I simply need to plus 0.06. That is correct. Alternatively, we can choose to always subtract the error. In this case, I will choose to subtract negative 0.06. I will elaborate. Okay? So, these are my answers first. I want you to check. Simply check the final answer.
Yep, I got it.
If your final answer is correct, your working is correct. Okay, hang on. If your answer is correct, all these highlighted ones are correct, you are correct. Your working is correct. Now, working can be shown this way, in green color, or some of you will do it this way. Okay, another way to do it. Or this, no change. Some of you may do this. 3.60 plus 0.02 to get 3.62 cm. You may do this. 8.32 plus 0.05 to get 8.37 cm. And 2.36 plus 0.08 to get 2.44 cm. Okay, all these are correct. Yes, all that we are doing is mathematics. They are all correct. Up to you, what do you want to use? I choose to do what is in green over here. I always minus. Okay, and then the error over here, sometimes it is positive number, sometimes it is a negative number. When I minus a positive number, everybody can do it. Primary school kid also can do it. When you minus a negative number, that is when your mathematics teacher will teach you that we are actually adding. Yes. Is it a must to show working? Yes, it is. It's just one step. Not too difficult, So show the working.
What?
Sorry? Yeah, both are correct.
But you have to show working.
But you have to show working, yes. Okay? I want to see how you handle your zero error. Moving on. Instrument. Oh wait, I just realized something. Over here, can I leave my answer as 2.4 cm? Why isn't it a good idea? Yeah, for vernier calipers, we have up to 2 dp, right? So all these readings are from vernier calipers. So if I have a corrected reading of 2.40, I should leave it as 2.40 cm. Can you imagine if this is your answer? Then somebody else looks at your answer and it says, I think this student used a meter rule, right? Because only 1 dp ma. So the person who doesn't know what you use, looking at your value, will think that you used a meter rule, but you didn't. So in order to avoid those kind of misunderstandings, we have 2.40 cm. Okay? It shows us the precision. Now, all these, check your answers. Tape measure and meter rule, same precision. I've got one more to add. Micrometer, screw, gauge. Micrometer, screw gauge. We will learn more about this instrument in future. Just know that it is more precise. Okay, next. Find the volume of the stone in the diagram. Do you get a correct answer? Is it easy? Yeah, 11.3, yeah? What if I choose not to have this? What do you think of this answer? 31.7 minus 20.4, you get 11.3. Yeah, I don't know what you are referring to. So I insist that you write this. You can choose to minus mark for yourself. Put it in green, volume. Okay? I insist that you write all these things out.
Right, okay.
Volume equals to blah blah blah. Okay, moving on. Time taken from A to C is 0.6 seconds. Does A to C count as one full cycle? Yeah, it's half a cycle. It needs to go back, right? Remember the wall fan? We needed to wait for it to go back to its starting position before we can say that it has finished one cycle. So the period. So look, all these should be good habits for you. Period equals to 0.6 times 2, you get 1.2 seconds. Okay? Now question. What is the time taken for 10 cycles? 10 cycles. What is the time taken? 10 complete cycles. How long does it take?
Oscillations.
Yeah, 10 complete oscillations. How long does it take?
6 minutes.
Okay, so time
6 seconds.
for 10 oscillations equals to 10 times 1.2. 1.2 is the time for one cycle, right?
12 seconds.
So we get 12 seconds. Okay, so I'm giving you this example because the next one says, what is the time for 2.5 oscillations? So if it's 2.5, this becomes 2.5, and this over here is 2.5. And I will get a different answer, which is 3 seconds.
Actually, you can don't need 2.5 because 10 divided by 4, you get 2.5.
Yeah, you can do that, but those are extra steps which you don't need to waste time on. Okay, so we have 3 seconds. Yes? Sorry? The 3.0? Yes. Put in a 3.0. Okay? Next. A student lengthens the pendulum. So he made it longer or shorter? Oh, there's already a seconds provided, so you don't have to write it. Okay? So, lengthens. Make it longer or shorter? When you say lengthen, we make it longer, right? Okay? Then he measured the time taken for 20 oscillations. Then this person, too much free time. He repeated the experiment 4 times. Very free, right, this guy? Why do you think he wants to do that?
Increase the reliability and accuracy of the experiment.
Okay, repeating the experiment 4 times is to increase the reliability. He is correct. It is more reliable. We are removing, we are taking into account all sorts of other random errors that could happen. Okay, so by repeating it 4 times, we take the average, we increase the reliability. So that we can say, I'm very sure that it's correct. I did it 4 times already, I'm sure it's correct. It is reliable. Now we also take 20 oscillations instead of just 1. Why? Why do we use 20 oscillations instead of just 1? Minimize what? Human error, yes. Initially, our human error maybe is 0.2 seconds. If I repeat it 20 times, I divide by 20. My human error becomes very small. Okay, so those are the reasons. And these are the results. Calculate the new period. I want the time taken for 1 oscillation. So I got so much information. Can find first the average for 20 oscillations. Okay, simply add everything up. This is a division. Divided by 5. You are not allowed to use the dash. Use the division.
They didn't give the question.
What?
They didn't give the question. Sorry, I don't know.
Oh, okay, so please copy this down. Calculate the new period of the pendulum. So all that we needed to do was to find the average. We did the experiment total 5 times. We repeat 4 times means total you did it 5 times. Okay, so out of all these 5 answers, we add them all up, we find the average. And we see that, it is actually equal to 34.456 seconds. Next, these are the times for 20 oscillations. I only wanted 1. So I divide it by 20 to get 1.77 seconds. If I use a shorter pendulum, the period reduces, it is decreased. If it is a heavier bulb, I use a heavier bulb at the bottom, it doesn't affect at all. If I change the angle of displacement, how much I swing it to the side, no effect again. Okay, these are extremely important.